Okay, so this lesson we're going to look at special parallelograms. In the last one we looked at parallelograms and we learned some things about that. We're going to look at some special ones now. And so the first one is going to be what's called a rhombus. It's a parallelogram with it's a parallelogram, so all the conditions of a parallelogram are in play, and these additional ones. So all the characteristics of a parallelogram plus all of these. So what is a rhombus? Well, rhombus characteristics are the diagonals are going to be perpendicular bisectors of each other. So not only do they bisect each other, they are also going to be perpendicular to each other. Secondly, all the sides are congruent. So in a rhombus, all the sides are the same length. Okay? And the diagonals bisect a pair of opposite angles. That means this diagonal will bisect angles A and C, and this diagonal will bisect angle B and D. Okay, so that's what it means. And so these two angles are congruent, those two, and those two. Okay, so that's the characteristics of a rhombus. Okay, so then the next one we want to look at is the rectangle. A rectangle is a parallelogram. Kind of obvious because opposite sides are parallel and of equal length. Okay, and all the characteristics of a parallelogram are in play, plus these additional ones. What is additional to this? All four angles are 90 degrees. That's what makes a rectangle unique from other parallelograms. And the diagonals are the same length. See, in a rhombus, the diagonals are not necessarily the same length. Okay. For the rhombus, kind of think of the diamond. A diamond is like a rhombus. In the rectangle, the diagonals are exactly the same length. Okay. And all other characteristics of the parallelogram. So then the last special parallelogram that we're going to look at is the most that uses all of the characteristics of basically of everything. Like if a rhombus and a rectangle got together, then you get the square. What is a square? A square is a parallelogram with additional characteristics. All the characteristics of a parallelogram, all the characteristics of a rhombus, and all the characteristics of a rectangle. That's what a square is. Mostly we just think of it, well, it's all four sides are the same length and all four angles are 90 degrees, and that's true. But additionally, we know then the diagonals will be the same length. The diagonals will be perpendicular bisectors of each other. Okay. We know that the opposite angles are bisected by the diagonals. So that means I know, since this is a 90-degree angle, I know these are both 45s. All of these are 45 angles. So I know all that. Okay. So that's the things about a square. And so let's look at some problems that we might be able to solve using this information for special parallelograms. So let's start with these questions right here. Each quadrilateral is a rhombus, so these are both rhombus. What is the measurement of angle MNO? MNO, so this whole angle over here. Okay, so what do I know? Well, some things that I know is this. I know that the measurement of angle NOM equals 62 degrees. Why? Because the diagonals bisect opposite angles. So I know that this diagonal bisected this angle over here, which means they're both 62. I also know then that angle NOL equals 124 degrees because you just add the two together, angle addition. I know that the measure of angle MNO plus the measure of angle NOL is 180. Remember, why? Because consecutive angles are going to be supplementary because it's a parallelogram. So working these things out using the numbers that we know, then I know that the measurement of angle of MNO is 180 minus the 124 from that angle, subtract it over there, and gives me 56. So there is how I can do angle stuff. Over here, I have these two sides measured, and this diagonal is measured. I want to know what QT is. QT is here to here. QT is part of the diagonal, and what do I know about diagonals is that they are bisected. Okay, so they are going to be bisected. Because of the expressions, I need to find what y is. Because this is a rhombus, I know the two sides are of equal length, so then I can write the equation as such, and then solve for y. So moving things around and all that kind of stuff, and you're going to get y is equal to 4. I can then come over here and figure out what QS is. Since y is 4, then QS is 5 times 4 minus 4, which is 16. And I know that QT is 1/2 of QS, which means this is 8. And there you go. Okay, let's look at some more examples. A rectangle with area 1,600 square meters is 4 times as long as it is wide. What is the sum of the diagonals? That's a little weird, but there you go. So what do I want to do in this case? In all cases that deal with geometric shapes and such an area, you always want to draw a picture. So draw it as best you can. There's that. I'm going to label it A, B, C, D, just because I might need reference angles and such. It has diagonals. Since I want to find the sum of the diagonals, let's draw those in. There's a diagonal. Here's a diagonal. And what do I know? I know that it is 4 times longer than it is wide. Okay, so if I want to use, we also have an area. So what is the area of a rectangle? Is the length times the width. And since they're using long wide as it is wide, we want to get in this fashion. If I put this as a length of W, or even just call it X, if you will, then this must be 4 times that. So if this distance is X, then this is 4 times that. And then I can take this information and plug it into this formula and get my equation in that fashion. So this tells me I have 1,600 is the area. This is a 4x. This is an x. And so I have 1,600 is equal to 4 times x squared. I can then solve this for x squared. Divide both sides by 4. X squared equals 400. Take the square root of both sides. So x is plus or minus the square root of 400. But you can't have a negative length. Since x is a length, we're not going to do negative lengths. So we're just going to take the positive version of this, which is going to be 20. So if x is 20, then what is the length of this? Well, this, because it's a rectangle, is a right triangle. And we already know Pythagorean theorem, so I know that the length of AC, okay, is equal to this squared plus this squared. Well, this is 80, and this is 20. So AC is the square root of 80 squared plus 20 squared. And then we can work this out on a calculator or simplify it by hand. And if you simplify it by hand, you're going to get 20 times the square root of 17. And since the diagonals of a rectangle are equal, they are the same length, I know BD is the same value. So BD is AC is that. And so their sum is literally 2 of those, which is 40 times the square root of 17. And then you can use a calculator, like I said, and you should have something very close to 82.462 meters. And so that's how I can do that. Here's another example. A square ABCD has diagonals AC and BD. What is the measurement of angle ABD? To help with this, and then explain how I know. To help with this, you should draw a picture. You should always draw pictures of geometric shapes that they're given to you. We want to label these things, and you can label it however you want. C and D, diagonals. Okay, so it's a square. Where is angle ABD? ABD. So I want to know this angle right there. So the measurement of angle ABD is equal to 45 degrees. Why? Because it says explain. Because the diagonals will bisect opposite angles, and each angle is 90 degrees. So if I cut it in half, it has to be 45. So that would be a reason for that. Let's look at a couple more examples of things I can do. So again, parallelogram, ABCD. I gave you some information, some expressions for each of these two things. And what must be true about this triangle, what must be true about this parallelogram to be a rectangle? Well, let's draw it. Assume it's a rectangle. Okay. It may not look it, so we don't really know that it is until we are found out that it is. I have diagonals because AC is a diagonal, BD is a diagonal. Okay. So what must be true for this parallelogram to be a rectangle? Well, what do I know about rectangles and their diagonals? Well, I know that the diagonals have to be of equal length. They have to be congruent. So for this to be a rectangle, AC has to equal BD because the diagonals must be congruent to be a rectangle. So if that's the case, what does the W have to be to make this happen? So what is 3W minus 1 has to equal 2 times W plus 6. And then we solve this for W. Minus 1, 2W plus 12. Start solving this out, and you're going to get W equals 13. Okay, so for ABCD to be a rectangle, AC must equal BD, and W equals 13. That's what has to be true. All right, I have one more down here. So here is a rhombus, or excuse me, is this a rhombus? Explain. There's a couple ways to do this one. This is by no means, all of these have more than one way of doing these problems. So here's the way I chose to do this one. I'm looking at this, and the characteristics of a rhombus that I do know is the fact that the diagonals are perpendicular to each other, which means this is a 90-degree angle. In fact, all four of these are 90 degrees. Okay. I also know that, I label this as an X, excuse me. This point of intersection right here is X. So I know it's 90 degrees. Actually, I didn't know in this picture, but I can look at it, this thing right here. These are bisected from these marks right here. I'm going to show that that's 90 degrees by saying, okay, I know the sum of the angles of a triangle is 180. So 32 plus 58 plus the measure of angle, and I put lettering on here, M, N, P, Q of M, X, Q equals 180. So then adding these and moving it over shows me that the measure of angle MXQ equals 90, which was what I just right there. And because the diagonals are perpendicular bisectors. When I first started it, I did not know that was 90 degrees. I knew they were bisectors, but I didn't know it was 90. I've now shown that that's 90. So they are perpendicular bisectors. Then that is one of the characteristics of a rhombus. Okay, some other ways that you can do this problem. You can go and deal with the opposite angles being bisected is another approach that I did with this one. But there you go. We'll finish this up in class, and that ends this lesson.